Hello, today we want to tackle a question on questions of straight lines, and the question is a structured question, of which part A of it goes that a straight line L1 whose equation is 3y minus 2x minus equals to -2. The question meets the x-axis at a point R, so they want us to determine the coordinates of that point R. Now, we know that the equation of a line is supposed to be in the form y is equals to mx plus c, where m is the gradient and c is the y-intercept. Now, given that, we will take our equation, which is 3y minus 2x equals -2. So if you rearrange this equation to be in the form y is equals to mx plus c, that means we are going to add 2x on both sides and end up with 3y is equals to 2x minus 2. So divide both sides by 3 and you end up with y equals to 2 over 3x minus 2 over 3. Now from this equation of a line, we can affirm that the gradient m1 is 2 over 3. So this gradient, we will place it aside and we will use it later on. Now, we know very well that if the line cuts the x-axis at a point R, when the line cuts the x-axis, it means the value of y is 0. So where the line meets the x-axis, the value of y is 0. So equating the value of y in our equation above, we are going to have the equation y is equals to 2 over 3x minus 2 over 3. So equating for the value of y equals to 0, you're going to have 0 equals to 2 over 3x minus 2 over 3. You add 2 over 3 on both sides, and then you simplify and you find that the value of x equals to 1. So it means that the coordinates of R, coordinates where the line meets the axis, is going to be the value of x and the value of y. So the value of x is 1 and the value of y is 0. So the coordinates of the point R is 1, 0. So we'll place the coordinates of the point R aside to be used later. Now let us look at part B of the question. Part B of the question. So we'll move our first gradient m1 and say the point R to our first part of the question. So we'll move them. Then we will look at part B of the question. A second line L2 is perpendicular to L1 at R. So find the equation of L2. Now, testing the knowledge on perpendicular lines, and you know that if two lines are perpendicular, then the gradient of the first line multiplied by the gradient of the second line must give us -1. So we should recall that m1 multiplied by m2 equals -1, where m is the gradient. So taking the gradient of the first line multiplied by the second line should give us -1. So divide both sides by 2 over 3, and you find that m2 is -3 over 2. So the gradient of line 2 is -3 over 2. So we'll place this gradient aside to be used later. Now, they want its equation. Now we are going to take a point on the line and use that point and R to find the gradient. So gradient, you know, is a change in y by change in x, and this one should give us the gradient. So when you cross multiply, it ends up to 2 into brackets y minus 0 equals -3 into brackets x minus 1, close the bracket. This one simplifies to 2y equals -3x plus 3. So divide both sides by 2 and you end up with y equals to -3 over 2x plus 3 over 2. So you can see the gradient -3 over 2 there is visible in the equation. So the equation of line L2 is -3 over 2x plus 3 over 2. So that is y. Now we are going to look at the third bit of the question, part C of the question. Now let us move our M2. Now, part C of the question says a third line L3 passes through negative 4, 1 and is parallel to L1. So find its equation. Now, the concept of parallel lines is that for parallel lines, if two lines are parallel, then their gradient is the same, or their gradient is equal. So if L3 is parallel to L1, so it means that the gradient of M1 equals to the gradient of M2. So in this case, the M3 is going to be 2 over 3. M3 to stand for the gradient of the third line, that is line L3. So given that the gradient is 2 over 3, let us find the take a point on the line. Then we use this point and the point negative 4, 1 to find the gradient. And this one should give us the gradient, which is 2 over 3. You cross multiply and you end up with 3 into bracket y minus 1. Close the bracket, equals to 2 into brackets x plus 4. You simplify, then you simplify further, then divide both sides by 3, and you find that y equals to 2 over 3x plus 11 over 3. So that is the equation of line L3. We go ahead and look at the third bit of the question that says determine the coordinates where L2 intersect L3. Now, where two lines intersect, we solve the equations simultaneously, or equate the values of y, because all of them are y equals 2. So you equate the two equations and you solve them, or you solve the two equations simultaneously to find the value of y and x. Now, recall that line L2, the equation is y is equals to negative 3 over 2x plus 3 over 2. And L3, it is y is equals to 2 over 3x plus 11 over 3. So, where two lines intersect, we will solve this equation simultaneously. So, we will solve the equation simultaneously. And this one is by subtracting. So, when you subtract y minus y, you will get 0. Equals to negative 3 over 2x minus 2 over 3x, and this one you get negative 13 over 6x. Then next, 3 over 2 minus 11 over 3, and this one you get negative 13 over 6. Add negative 13 over 6 on both sides, and you end up with negative 13 over 6x equals to 13 over 6. So solve this one and find the value of x equals to negative 1. So substitute the value of x in any of the equations, either question L2 or L3. So equating it in question L2, equate it in question L2, and you find that the value of y equals negative 2 over 3 plus 11 over 3, which translates to 3. So the coordinates where these 2 points intersect in the form of x and y is going to be negative 1, 3. So this is a structured question that is trying to test on the concept of gradient and equations of straight line, specifically parallel lines, perpendicular lines, and it's also testing on where two lines are meeting or are intersecting. So you have seen that where two lines are intersecting, we're going to solve those two equations simultaneously. And when you solve those two equations simultaneously, you find the value of y and the value of x, and that one creates our coordinate. So that is how that question is supposed to be handled step by step. Thank you for watching and learning. You can like, follow, and subscribe to my social media handles, Facebook and YouTube. It is on BC Online Math. May you be blessed.